Okay, guys, hi. This is part three of the test for review screencast. I'm on page six, and you'll see at the top of page six, this is a kite question review. So you can see that quadrilateral ABCD is a kite, right? And they're asking you to find both X and Y. So let's see what we can do with this. Okay, so I think we are going to start off. Well, we can start with why? Because I think that's the easier one. When they have a kite drawn with its diagonals in place, chances are they're going to want you to use triangles to solve, or at least for part of it. Okay. So you can see they want you to find this angle right here, Y. Okay. Now they are nice enough to give you this angle right here, C. So we've got this triangle right here. We want to find angle Y. We know angle 59, right? 59 degrees right here. Do we know anything about this angle right there? Yes. At the intersection of the two diagonals is a right angle. We know that's 90 degrees. So that's great. We now have the three interior angles of that triangle. So Y plus that right angle of 90 plus the third angle of 59 degrees all equal the sum of the three angles inside of a triangle, which is 180. So let's combine our like terms. This will be 149. Let's subtract 149 from both sides. And we have 31, right? So that's going to give us y. Y is 31, and since it's an angle, let's call it 31 degrees. Okay, so over here, they want us to find x. So they tell us this angle right here, angle A, is 4x minus 3 degrees. So we're going to use this triangle right here to solve. We've got a couple of ways we can do this. Yeah, this is the way I'm going to do it. So we're looking for this angle A. Do we know anything about this angle right here? We sure do, because the diagonal bisects this larger angle right here, mean it cuts it in half. So if this half is 41 degrees, so is this half. That's also 41 degrees. Do I know what this angle is? Sure, that's the right angle that's formed by the intersection of the two bisectors. So yeah, we have all three angles. So we can, again, since the three interior angles of a triangle, let's set that equal to 180. We know that angle A is 4x minus 3 plus that angle at the top, this angle D, is 41 degrees. Plus this third angle right here is our right angle. That's 90 degrees. Okay, let's combine our like terms. We've got 90 plus 41, which is 131, minus 3, which is 128. So we have this. Positive 128. I'm sorry, guys. It's positive 128. Let's subtract 128 from both sides. That's going to be what? 52. So 4x equals 52. Divide both sides by 4. X is equal to what? 13? Yep, x is equal to 13. So we have x, we have y, we're good to go. Now, if I asked you for the measure of this angle right here, you guys would know what to do, right? You would substitute x in for the x here and solve. Just check in on you. Okay. So this brings us to a couple of questions on sets. So this is what we talked about Friday. We have these two sets, set A, set B, written in what we call roster notation. In other words, the elements are just listed with commas between them. And we want to determine for A, right here, the n of A. In other words, how many elements are in A? There's 1, 2, 3, 4, 5, 6, 7, 8. So the n of A is 8. Our next question is a true or false question. The statement is 7 is not an element of A. Is that true or false? Well, there's 7. 7 is an element of A. So that statement right here is a false statement. The next question is another true or false. Let's look at set B. Is 1 an element of set B? No, 1 is not an element of set B. So that statement's false. Now they want to know A union B. Remember, union, you're uniting the two sets. You're going to list all elements of both sets and combine them into one set. So there's me listing all the elements of A. Now I'm going to add the elements of B. I can write 5, 6, 7 again or not. I'm not going to. You could. And there you go. So that is a union. Remember, this U is union. This upside down U is intersection. Remember, intersection is in common. What do they have in common? All right. So is there a 1 in B? No. No 2, no 3, no 4. 5 they have in common. 6 they have in common. 7 they have in common. 8, no. 10, 12, no. So my set of A union B is 5, 6, and 7. Sorry, intersection, not union. State a proper subset of A. Oh, there's a ton. Um, a subset can be the null set. It can have one element in it. It can have all of the elements in it or anything in between. I'm just going to randomly choose 2, 3, 4. That would be a subset. Okay. This next table here is reviewing what the different symbols and types of numbers are. So we start with the natural numbers. Natural numbers, are the counting numbers 1, 2, 3, 4, dot, dot, dot. It is infinite. Okay. Q. So Q are the rational numbers, numbers that can be written as a ratio, as a fraction, as long as when that fraction is divided, the decimal cannot be um, infinite. Okay, so the decimal has to result in a finite number of numbers or it's got to be repeating. So rational numbers would be things like, um, negative 2/3. It could be zero point 0.7. It could be 5/10. It could be 2.1. It could be negative 3.3 repeating. And there's an infinite number of rational numbers. So, yeah. Okay. This next set of numbers are whole numbers. They include both the negative and the positive aspects of them. So those are integers. Integer symbol is Z. Okay. R are our real numbers for us, just about anything you can imagine. So you could have pi, you could have 1, 2, 0.73926. You could have negative 50. Okay. So numbers, pretty much every number that you can remember would be a real number. And then finally, our whole numbers are just like the natural numbers, but they include the number or include 0. And our symbol looks something like that. Okay. All right. So now they're actually reviewing numbers. They want to check everything that's true. Okay. So this negative two thirds, it can't be a natural number because it's negative. It can't be an integer because it is not a whole number, but it is, well, let's just write this up here just in case you forget. Z is integer. Whoops. Q is rational and R is real. Okay, this is not natural. It's not an integer. It is a ratio. It's real. Okay. The square root of 7 is not a whole number, so it's not natural. It is not a whole number or a negative number, so it's not an integer. It can't be written as a ratio, but it is real. Okay, this next number, not a natural number because it's not a counting number, not an integer because it's not a whole number. It is a rational number because it's got a decimal that ends and it's real. Okay. Square root of 16 is actually the number 4. 4 is a counting number, so it's natural. It's natural, it's also an integer, it's also rational, and it's also real. 2 pi. So we learned that pi is irrational, so 2 times pi would also be irrational. So it's none of these but a real number. Negative 11 is an integer. It can't be a natural number. It's not a counting number. It's a negative whole number, which, if it's an integer, then it's rational and it's real. 6 divided by 0 is nothing, right? It can't be done. So we're not going to check off any of those. And then finally, the negative square root of 2, that's an imaginary number. I'm not going to ask this, so don't worry about that. Okay, I won't ask this either because they're tricky. But the other ones I think are all fair. Okay. State the following set notation in words. So the curly bracket is the set of, then we hit uh, real number X. My straight up and down line is such that. Now we're going to see that X is lying between 3 and 8. And since they're both have the and equal to sign underneath it, we're going to use the word inclusive. So let me put that in words. Such that X lies between 3 and 8 inclusive. It includes both 3 and 8. Okay, put that in quotes. All right, let's do the last one. Quote, curly parentheses is the set of X's such that X lies between 3 and 8, and X is an integer, because that's what the Z means. Okay. All right. So now they want us to write these sets in interval or set builder notation. So set builder notation always begins with that. It always has an X written. Um, if it's not specified, we're going to say X is a real number such that. So this means if it connects 2 points on the number line, X is going to be between 2 numbers. The number is -4 and 2, right? So X is greater than, so X or equal to -4, and x is less than but not equal to, because that's an open circle. That's my answer. Okay. You could also write it like this. If you like to put comma x is a real number. Okay. All right. Next one. Set notation. Curly parentheses. X, not specifying. So x is we'll say it's a real number such that x, so there's only one point here. So what is x greater than, or is it less than -3? It's going this way on the number line. It's greater than. Is it equal to? Nope, it's an open circle. So you're just going to say x is greater than this number here, which is -3, the end. Okay. All right. This next one, so we've got two separate sort of number lines on here. So we're going to be using the word or when we see this space between the lines. So we're going to say the set of x, x's that are real numbers, such that x is greater than, no, sorry, x is less than, but not equal to, because that's an open line. X is -5, so x is less than -5, or there's our, gap right here. X is greater than, closed circle means, or equal to, what's this number right here? 2. Okay. And then finally, this last one, the set of all x's that are real numbers, such that, so x is lying between these 2 points. So we're going to put x in the middle. I'm going to put this number to the left of x and this number 6 to the right. X, we're going to have the greater than facing the x. X is greater than, but not equal to, because that's an open circle. 1, but x is less than, but not equal to, 6. Close my parentheses. Okay, now we're representing on the number line. Okay. So again, this is just notation, another way the set interval notation can look. We need x, we need to find -1. So I'm going to draw it above. It's x is greater than or equal to, so that means it's a closed circle. We're going up to 5. You might be drawing this right on the number line. That's an open circle at 5 because there is no equal to. All right, the next one. X is a real number. So the set of all x's that are real numbers such that x is greater than 2. Let me find 2. There's no greater than or equal to, so it's an open circle. So there's 2. X is greater than 2. Go that way. Or x is less than -1. So let's find -1. It's not equal to it. It's just less than. So open circle, we're going that way. Okay. Now, just a quick review of union and intersection. So the upside down bridge means intersection. So we need to find the shared elements of A and B for this. Okay. Don't worry about the universal set. We just never really went over that. So let's take a look at A. What do they have in common? Both A and B have -1. So intersection in common. You can think of it that way. Do they both have 1? No. Do they both have 2? Yes. They don't both have 3. They don't both have 6. So this is A intersection B equals that set. A union B, now we are going to unite the elements in the two sets. Okay, so I'm going to write all of A, 1, Duh. Now I'm going to add B to it. Now, I don't like to rewrite the numbers, but you decide what you want to do. So I'm not writing that -1 again. I will write the 0. I'm not writing the 2 again. There's the 6. Done. Okay. Oh, that was quick. All right. So that's the end of the screencast, you guys. Good luck in your studying, and let me know if you have any questions.